Okay, listen my dears. So now we are going to discuss about a very important fault in unsymmetrical fault category, that is nothing but a single line to ground fault. Okay, so consider an alternator. Okay, fault is occurring across the alternator or power system, correct na? So consider an alternator which produces the voltage EMF EF, and see, before fault occurred, my dear, before fault VA comma VB comma VC balanced. We know that na, right? And IA is equal to IB equal to IC is equal to 0. 0 in the sense the alternator is not delivering any of the load. You imagine, okay, the alternator is not delivering any of the load means initially the alternator terminals are open circuit. Alternating terminals means simply you can extend it into a power system, okay, no worry. And the neutral is earthed via a neutral impedance of Zn. Okay. And if it is directly fell into the ground, that is the fault condition. If phase A is fell into the ground is the fault condition. Any one line can be fell into the ground is called the single line to ground fault. For the simplicity, I am representing A is fell into the ground, so it is the single fault, okay, single line to ground fault. So this is the before fault condition. And after fault, what happened, my dear? After fault what happened means VA, VB and VC unbalanced, correct na? After faults what happened? VA, VB, VC, that means the voltage across A, B and C will be what? Unbalanced. That is the nature of fault. That is the nature of unsymmetrical fault. And what about the current, my dear? The current IA will be now equal to, that is the current now flowing will be, if it is grounded means the neutral also grounded, this ground and ground can be connected together so that there will be a flow of fault current from this ground via Zn to this EF to this reactance and to this and to ground. So that will be the closed path of the fault current. That will be the closed path of the fault current. So I can say that after fault, the IA will be now represented like a fault current, because now this IA is not the previous IA. Previous IA was what, my dear? 0. Previous IA was 0 because it is open circuited. There is no load connected at all. But after the fault occur means there will be a flow of current. There will be a flow of fault current. This is called nothing but, my dear, fault current. So this IA will be now be termed as the fault current. IA will be now, we can term it as a fault current. And same that IB equal to 0 and IC is equal to 0. There is no change at all. So you have to find our aim, actually, my dear, our aim is to find the fault current IF. Our aim is to find the fault current IF. Okay. For that, I can use this. I already told you now that matrix can be utilized here. I can use here. That means if you have IA, IB, IC in your hand, you can calculate IA1, IA2 and IA0 from the IA vector. How can we calculate that? It is nothing but 1 by 3 into 1 A square, 1 A square A into IA, IB, IC. Correct, my dear? I already explained this. I already gave you this matrix equation, correct? So this IA0 can be IA1, IA2, this can be calculated that IA0 1 by 3 into 1 A square and 1 A square A, IA, IB, IC. What is the value of, my dears, IB and IC? Is there any IB and IC now? No. Is there any IB and IC? No. That is 0. So find the value of IA0 now. 1 by 3 into IA. Correct? Is there any other matrix happen? No. IA0 is equal to 1 by 3 into this plus this into this into 0. And what is IA1? Again 1 by 3 into 1 by 3 into IA. And what is IA2? 1 by 3 into IA. So I can say that, my dear, as a conclusion I can say that, IA0 equal to, IA1 equal to, IA2 equal to, IA by 3. IA by 3. IA by 3. This is the very important relationship in line to ground fault. That means the positive zero sequence equal to positive sequence and negative sequence, and will be nothing but the IA by 3. IA is nothing but the fault current, correct? IA is nothing but the fault current. IA is nothing but the fault current. Is it clear, my dear? Is it clear? And the equation for the fault current IF will be equal to, which is nothing but IA. Fault current IF equal to this IA equal to IF. 3 times IA0, correct? 3 times IA0, which is nothing but, my dear, 3 into EF divided by Z0 plus Z1 plus Z2 plus 3 Zn. This equation you just mug up, my dear. Actually there is a derivation for this. We don't want any derivation now. We just by heart these two. That's all. By heart these two. That's all. So the fault current IF, that is our aim. Whenever there is a single line to ground fault, what will be the fault current? That is our aim. In order to find the fault current, IF will be equal to 3 times EF divided by Z0 plus Z1 plus Z2 plus 3 Zn, where Z0 is the positive sequence, sorry, zero sequence impedance, positive sequence impedance, negative sequence impedance, and neutral impedance. And this will be per unit. This will be in per unit. Normally this will be in per unit quantity. Okay, this will be in per unit quantity. Is it clear, my dear? Is it clear? And another term you have to note here, one more term you have to mention here, that is short circuit MVA. Normally in the examination this will be asked. Short circuit MVA. Short circuit MVA, very very important term, my dear. Short circuit MVA is nothing but, MVA is nothing but, my dear. That means at the time of the fault occur, if you place a circuit breaker here in order to break the fault, at the time of fault occur, if you definitely, we don't want this fault for days or hours now. Whenever at the instant of fault it happen, you have to remove it. It should be removed. With what help we will remove it? With the help of a circuit breaker, we have to remove it. Relay will sense the fault. I will later we will discuss study of this relay and circuit breaker. But for general, you are as an electrical engineer, definitely you should know this. Sensing of fault will be by relay. After sensing the fault, relay will send the message to the circuit breaker so that the circuit breaker will be tripped. The relay will be tripped and circuit breaker will break. So this breaking of circuit breaker will happen as soon as the fault occurs. What will be the power across these two terminals of the circuit breaker after the break, just after the break of circuit breaker? That is called the short circuit. MVA means power, apparent power. MVA means in apparent power. So short circuit MVA is nothing but, maybe there is an equation for that also. Short circuit MVA is nothing but normal MVA rating or base MVA rating. This divided by percentage reactance. Suppose I will say an example. Suppose it is a 500 MVA alternator and the percentage impedance is 16%. Imagine it is a 16% impedance. Then the short circuit MVA will be convert this percentage into 16, that is 0.16. If you divide this, that much will be the short circuit MVA. That's all. While solving problem, we will cover all these sessions, my dear. Don't worry. This is just a theoretical session actually. So after this, we will do a problem. After we complete the syllabus, theory syllabus, we will do lot of numericals in previous year exam. AE examination. Previous year AE examination all across all India we will cover. across all India, JAE previous year paper we will cover, and after that definitely this problem will come and I will definitely explain at that time. Now now also I explained it, but more problem will face there and we will solve. Okay, that's all. I think you will be along with me for a very long time, not for now. Okay, so we will discuss, don't worry. So just need this in one word question, my dear. There will be a beautiful question asked. There will be a beautiful question asked. You have to remember one thing. Whenever there is a neutral or there is a ground connection, then only zero sequence component will come into play. If there is no ground connection with respect to the fault, then there will not be any zero sequence component. There will not be any zero sequence component. Okay, one word type of question. Definitely you will see this question many times if you do previous year papers. That means, which of the following fault doesn't contain zero sequence? The options, I think the electrical inspectorate examination of that question was there. That means, which of the following fault doesn't contain zero sequence? Option LG, LLG, LLLG and LL. The answer is LL, because only that LL fault doesn't contain any ground. If there is no ground connection, means there will not be any zero sequence component, my dear. Zero sequence component. And one more thing I will tell you, my dear. The alternator always contain the positive component only. There will not be any negative component or zero negative sequence or zero sequence component of alternator. Alternator is always contain the positive sequence. These all are one word question actually. Okay, positive sequence. Okay, so alternate is always containing positive sequence. Then a transmission line maybe it contain positive, negative, zero, everything it may contain, but the alternate contain only positive sequence. Okay, we will learn one by one when we face that problems. Okay, I will tell you. So just of now, so in the one word question examination you may also expect like, in which fault all the sequence components are equal? Option LG, LLG, LLLG, LLL. The answer will be LG, because only these all three sequence components are equal, which is nothing but IA by 3. And the fault current 3 EF divided by Z0 plus Z1 plus Z2 3 Zn. 3 Zn, where Zn is nothing but the neutral reactance. Neutral reactance. If the fault is through, it is directly through earth, na? Suppose the fault is through any other impedance. Suppose any other impedance the fault is happening. That impedance will be ZF. You imagine that is ZF. Then the equation will be slightly modified like plus 3 ZF also in the denominator. Plus 3 ZF also in the denominator. That also you should know. If it is not through any fault impedance, then directly up to Zn is enough. If there is through a fault impedance, then 3 ZF will also be there. 3 ZF will also be there. Is it clear, my dears? Is it clear? Okay. And one more thing. If earthing is not there, I will show you the beauty. If earthing is not there, earthing is not there means, my dear, Zn will be infinity. Correct, na? Zn will be infinity. So what happened to the fault current? IF is equal to 3 into EF divided by infinity, which is nothing but 0. Very important relationship, my dear. If we doesn't ground the Zn, it is not grounded means there will not be any closed path for the current. So the current will be 0. No issue. That's all. And if the ground is, if the ground is dead shorted, that means Zn is equal to 0. If the ground is dead shorted means Zn will be equal to 0, means simply IF will be equal to 3 into EF divided by Z2 only. There is no Zn at all. there is no sudden at all. For neutral is here solid ground. Okay, if the neutral is solid ground, if the neutral is, if earthing is not there, that means there is no, neutral is not grounded or earthed. If you are not there, for neutral, okay, for neutral, that word you specify, for neutral, then it will be. And if the neutral is solid ground means much simply connected to the ground. Sudden will not be there. Sudden will not be there. Substitute this in the equation and you will get the answer. That's all. Is it clear? Is it clear, my dear? So that's all about the single line to ground fault.